Okay. I don't have any money anyway, so doesn't matter. Somebody else, we won't get into that. All right. Yes, a student threw something at me and now I'm bleeding. I don't know who it was. Starting to put a Band-Aid on. Teaching in America. Anyway, so we watched an AP video and really wax on, say it, wax off. It's just you got to memorize these identities. This is a formula day. There's nothing really special that I can do about this. Okay, so what I will do to start the video is, yeah, whoa. I was getting my notes ready here. Oh, did I make copies? Yes, I did. Okay, good. I just want to make sure I'm ready to go. Yes. All right. So what I talked about in class is this rule right here. I don't know where to put it. Numbers of same base. I'm going to be like cave person talk. Number of same base multiplied together. You add the exponents. And I could do the same thing, and I don't think I'm going to go through the laborious task of writing the next two. That's what both of these rules. Oh, sorry. I was thinking of the AP video. How does this relate to this? Well, it's like these questions: x squared times x to the third. Everyone in this class should know that that's x to the fifth. You add those exponents, right? Well, that's what's happening with the logarithm. These right here. Here we go. I'll circle it. Numbers of the same base multiplied together, you add the exponents. And both of these logarithms, when you evaluate it, would represent an exponent. So that's why I can use this verbiage to relate our exponent rule to our logarithm rule. Usually when we do that, we can help a student memorize more, because that's all this is. This is memorization and then usage. That's the wax on, wax off. Just do it. Do these stupid little questions, and then you'll learn the rules better. By the way, one more thing you want to put. Here's some words, what each side represents. This is the condensed side. Condensed means turn it into one logarithm, make it smaller. That's what condensed means. This is the expanded side. Okay, so sometimes we just use the directions condense or expand. And you got to know the difference, okay? So it's just back and forth. That's really what it is. Wax on, wax off. Use the rule so that you can memorize. This is the this is the condensed side. This is the expanded side. This is the condensed side. This is the expanded side. So that's what you got to do. You got to put whatever way they want you to go, expand or condense. You got to get everything in the proper formatting. Oh, and then don't forget, I don't know why they throw this in here, but nice little thing again. Some people struggle with memorization. ln is log base e. So just know that when you come to those. Hey, do those first three, A, B, C. I'm going to walk around the room and see that you can do those first three, and I'll show you. And then the second three get a little bit more challenging. I'll break them down a little slower. So take a look at those first three. First one should be easy. The last one, notice what I highlighted. And I hope you could do the last one and the middle one in one step. I kind of showed you the first step for letter B, and I should have done that up in the rule as you're doing those. Up here, I like to do this on the power property. I like to say, well, here's that power. What ends up happening is it gets yanked out in front, right? And I didn't finish the statement that I said before. We have a quiz a week from today because we're really going to review. Although tomorrow we're going to keep going with this, just this. And then Monday we're going to look at inverses one more time. And then Tuesday, Wednesday is review. Monday is review as well. We've already done inverses. So just have another note sheet that we've used in the past. Well, the past was only last year. But that we used last year that I want to use again. So I'm a little worried about inverses and the algebra behind them. Okay, here we go. Blabber, blabber, blabber. We okay with this? Doink. Log base 4 of x times y. You don't need the parentheses. I just wanted to reinforce that condensing means bring to one logarithm. All right, and it is log base 4 of that product. Next one, you put the 3 as an exponent, and then it's a division. Everyone okay with that one? No one did. I see a bunch of people writing. Oh, I didn't get that one. All right? So the minus means division of these two arguments. Yeah, we're going to keep using that word argument, position inside the logarithm. All right, and then the last one. Well, hopefully you take a look at the last one. It's better to produce your own answer in 10, because I saw a lot of people write on letter B like they didn't do it or had to make a change. We have two minuses, so therefore we have two things in the denominator. Okay, and that's why we should be able to do this in one step. I could do it first by saying log base 10 of x over 5 minus log base 10 of z, but then you got to change that into one logarithm, and that means the z also goes in the denominator. I don't know how else to say it. All right, so it's really is kind of a one-stepper. All right, as far as that is concerned. Wax on, say it. You just got to do it. I don't know what else to tell you. There's nothing exciting about this lesson. It's impossible to make exciting. It's just questions to hammer the rules down. What does that become? Starts with an E. What does that become? Starts with an E. What does that become? Starts with an E. Exponent. So you yank these up here first. I'll slow it down. And then what does 1/2 power mean? Square roots. So really watch what I do. Log base 7 of a squared minus log base 7 of b to the 5th. Get my circles in the way. Plus log base 7. Okay, we got to be able to do two steps in one. What's the square root of 4? What's the square root of 4? 2. And if you did half of 2, you would have got lucky. Because luckily, half of 2 is also the same as the square root of 4. Or half of 4. It's the same as the square root of 4. So that's the case. And honestly, I have no way really of breaking this down. Who goes up in the numerator? Where does a squared belong? Top or bottom? Top. Okay. Again, it's just the guy right here. All right. And then where does b to the 5th belong? Top or bottom? Bottom. It's only Davin. Davin, you made the video. And then where does 2 belong? Top or bottom? Top. No one's answering. That scares me. That's what I told you about yesterday. What scares me when we do a quiz is, and there's 5 answers in a row. That's 1, 1, 1, 1, 1. And the 4th out of 5, 3 people miss. Right? Gotta lock it in. Okay, but anyway, and notice where I put the 2. You don't put a squared 2. You put 2a squared. And that's it. What did the directions say? Sorry. I think it does say condensed, doesn't it? Condensing. There you go. There's your word. Told you. Okay, now. I'm okay. No one move. What does this become? Starts with an E, everyone. Oh, no. So I got to be careful on this one. Slow down, Sparky. Log base 2 of the quantity xy squared. Now comes our algebra. And then what does this become, everyone? Starts with an E, an exponent. So I'm going to still write this like this. What does the 1/2 power mean yet again? Square root. So I'm going to go ahead and do that. When you condense, you want to turn fractional exponents into a radical. I guess if you left it as a fractional exponent, that'd be okay as well. I don't think I can mark that wrong. And then how do I square a product? That means you square both parts. So that's x squared y to the 4th. Again, it's not exciting. There's not much I can do about this. It is what it is. It's formulaic. Nothing to put bells and whistles on to make it all exciting and fun for the students. And then this becomes a product. And that's how it turns into one logarithm. Okay, so just a little bit more messy algebraic stuff to do. Doesn't end up being a really clean answer, but that's what it is. It's log base 2 of this whole ugly product. And there's nothing else to do. Again, if you left this y plus 1 parentheses raised to the half, I can't mark that wrong. I don't think there's a rule behind that. And I shouldn't. This is weird. I had to do this with the honors or the BCers when we were solving logarithmic equations. I need to turn this into one log, and this isn't even a log. But I just have a question for you. 2 is log base 6 of what number? Very simple question. Log base 6 of what number equals 2? 3, 2, 1, go. 3? What? No. I didn't hear the right number, or you're whispering too much. What number? 6, wait, okay, so, all right, 2 is a what? Starts with an E. Exponent. So 6 to the second power. I can't really get away. What's 6 to the second power, everyone? 36. I said it. Well, you didn't say it loud enough if you said 36. I said that? Did someone say that? Yes or no? Or are you blown away? Someone's crinkling their eyes. All right. Isn't log base 6 of 36 too? Yes. So I can replace that with this because it is equivalent. Did you say it?
No, I just thought you were saying 6 to the what power is 2.
Oh, no. Yeah. No. And you said 3 though? That's dividing. Oh, 1/3. Oh, that still doesn't work. Because that's a cube root of 6. Sorry, I'm shooting down a student. All right, anyway. Gotta put them in their place. All right, anyway. Log base 6 of x. Okay, so I want you to really focus on this one. This is really, yeah, it's a little jerky. Back in the day 2 years ago in the regular CAT class, we never did anything like this. But it's AP. They make you try to think of equivalent forms all the time so that, you know, all the time. So I don't know how you would know to have to do that, but, you just have to. Okay, now you want to get nuts? No, someone said no. Okay, now it's the reverse. Doesn't it say expand somewhere in the directions? I don't feel like reading. Yeah. A lot of times in the old book, that's all it said. Expand. That was it. No long worded, winded, directions. Expand this. That's it. Very clear, succinct, precise. What does a product become? What's a product become? Sum, minus, or it's one of those two. What is it? Add. So here, what's the base on this logarithm, by the way? 10. Be careful of that because if this was 10, then you would have to evaluate log base 10 of 10. What's log base 10 of 10? 1. So you have to turn that into 1, the opposite of what you had to do on this one when you had to turn 2 into some magic logarithm. All right? So it'd be the opposite of that. Okay, and then plus, sorry, my bad, dogs. Log. So expanding puts this in terms of multiple logarithms. Again, these are just for wax on, wax off, exercising the rule. When we come back from break, we're always going to condense in order to solve a logarithmic equation. And then I always like doing this, and many of you, once you get good with these, you probably could do this in one step. All right, the x has a squared on it, so that logarithm should have a 2 in front of it. The others do not have a squared on it, so there better darn well not be a 2 in front of those. Talking about tutoring, we are 2 days behind. I think I showed you that yesterday. I decided to stop and do evaluating logarithms and graphing because I felt we're still working on it. And then we'll introduce the new stuff today and tomorrow and hope for the best next week. Memorization got to be a thing. All right, log base 3. What's division? What operation, everybody? Subtraction. You either get it or you don't. You know what I am also going to do? 2 steps in 1. This is the quantity x plus 5 raised to the 1/3. For those that can't get those fractional exponent rules down, you get to practice those again. Yay. I'm so excited. And then what do we do with these exponents? Pull, anyone? Pull, anyone? Pull, anyone? Pull them out in front. You have no choice on this one. Remember the last one? Not sure. Do I have to change that cube root to or 1/3 power to a cube root? In this one, you don't really have to. You could have wrote this as y plus 1 quantity raised to the 1/3, and I think you're fine. You have no choice in this. You have to change this to an exponent so that you can pull it out in front. There is no option there. All right. Oops, sorry. Wrong. X plus 5. Now, this is not a rule. This does not turn into log base 3 of x times or plus log base 3 of 5. That's if it was 5x, if it was multiplied in there. So that's done. These are often mistakes that students make. They make up a new rule, and that's naughty, bad. Don't do that. Okay, that's done. Let's see if you could do this one. Let's see if you could get the final answer in one shot. I'm going to walk around. I am gonna do it in one shot. I'm gonna do it all in one. This is for the high flyers that, okay, I get it. I get it. Understand what's happening. This one's not too bad. Then on the next page is a new rule. We'll have you get your calculator out. If you're done with the C, go ahead and get that calculator out. Improve a rule and show you a cheating button on your calculator, which I think I might have already showed you. But then I'll show you the change of base. And really tomorrow, there's nothing new. Just gonna practice this again and then just hope for the best Thursday. It'll show up in the review again and you're either gonna memorize it or you're not. I know there can be problems in writing it down. When I get tutoring, I'm glad I have tutoring. I feel like I seem to think I might complain about it, but it really gives me an idea of what students are thinking and how it's working. So, all right, so here it is. ln of 3, because it's up in a numerator, plus what's square root of x the same thing as? What power? 1/2. So then that's 1/2 ln of x. And why is it plus? Because these are up in the numerator. So fat or a mac, maybe I'll do that. Plus, and there is a positive out in front of this, but I would never write it. I would never write it. And then these are in the denominator, so what should they have on them? Subtraction. So it's minus lny minus lnz. How many people got that all by their lonesome? Okay, only 2 hands. That's what I was shooting for. Okay, 2 hands. Did you get it? No? All right. I thought you just said you can't raise your hand because, yeah, it's hard. Anyway, nothing. Okay, now let's get our calculator out. We're going to prove this. Okay, this is called the change of base rule. Please understand the difference between this rule. Log, I like doing this, log base b of, let's say x over b, just to use the same letters. No, that doesn't quite work because that's the same base of the x over y. That's equal to log base, or I should reverse this. Okay, so log base b of x minus log base b of y. Why is he writing this? Because this is a common error, convoluting these two properties. There is a huge difference between what you see up at the top and what I just wrote below from our previous page. The subtraction rule. Those are not the same. Notice this doesn't say log base b of x over log base b of y. That is different than what is being shown here. Got it? Okay. Now, I got to open up my calculator and wait 5 minutes for it to open on this computer. I think it's opening. By the way, 4 to what power equals 12? What's 4 to the first, everyone? We just did this with the previous question. What's 4 to the second? 16. So what should this answer be between? We had actually questions like this 3 weeks ago. I remember this. So what's the answer between 1 and 2? Right? And you were asked those questions. And what is it probably closer to? It's probably closer to 2, because 12 is closer to 16. You were asked those questions before. Hey, there it is. That's from my BC class. But we're going to go ahead and do this one. All right, you bunch of cheaters. You people with these extra buttons that allow us to be more enumerate every part of our life, like the fraction button on the calculator. This is why we don't know fractions. Fumble! All right, anyway. Log base 2 of, wrong. Log base 4 of 12, fine. This button is relatively new. As a matter of fact, TI-84s might be only 10 to 12 years old. So back in the day, students didn't have this button, it didn't exist. So therefore, they had to have what was called the change of base rule. So they had to type this. Now, the smart bases we should be using are base 10, because I have this on our calculator. So go ahead and write this. Or the other one that we have on our calculator, the LN button. And these were the ones the students back 10 to 12 years ago had to type in order to evaluate logarithms that did not have a common base, let's say. You couldn't do it without a calculator. So I'm going to go ahead and do that. Okay, let's do that cheat button fractions. All right. Just you kids. And it's log 12. I don't even have to close that. Log 10. I don't think so. Or 4. Enter. Okay, no syntax there. See how you get the same answer? See? And we knew it's supposed to be close to 2, so that exponent makes sense. And then one more, cheating fractions and numeracy. LN12, I used that word yesterday when we were doing that quizzes. And I truly think a numeracy is crushing us, not the pre-calc. It really is. Input, say it. You can't input output if you can't deal with a number. It's true. Right? And then the other one, find, get the cheating button, or just do this. The old way was this way. Can I move this? Darn it. Darn it. Yeah. And there, the mouse never shows up. I get him moving around 34 times. He always complains. All right, this is what we always had to do in the old days. 5, 7, 8, then you had to close it. That's the numerator. Divided by, that's the denominator. Log 9. And then you don't have to finish that one off. 9 squared is 81. 9 to the third is obviously huge. So that's like between 2 and 3. 9 times 81, 9 times 2,000. So I think it's, I don't know what it is. I can't even say. All right. 2. That's weird. I'm going to check 9 to the third. Now I'm curious. 9 to the third. Oh, there you go. Oh, I knew that. I remember that number. So that's why it's 2.8. See what I did there? 578 is a little smaller than 729. I just wanted to check to make sure that answer made sense. 9 times 8 is 2. Yeah, I can't think. I can't think right now. Okay, and then now it's the AP questions. So yeah, you get a boring lesson today. I'm gonna go to the bell. We're not really gonna do that tomorrow. We're just gonna, I guess, we get a couple activities. Could show another AP video, see what she has to say. This is what the lady did. This is what the lady did in the thing. So it's really her situation there. And it might be the same ones. No, it's not. Okay, you can use laws to look at internal ways to write functions for the purpose of graphing. Right now, that's on the inside. That's a horizontal shrink by 1/4. We should know that. Okay, so maybe we'll write that one more time for purposes of, the AP test. And, oh, you know what? Sorry, purpose of our final exam. Horizontal shrink or dilation, but we have to say by 1/4 because when it's on the inside, it's an inverted relationship. But what does that turn into when we use our rules? Well, it's a product thing. So let's write it as f of x. And this is exactly what the lady did when she introduced these rules, but she didn't really introduce them. She just kind of shoved them in your face kind of thing on the AP video. And that's fine because it is just a formula and there's nothing really to do to derive it. Hey, everybody, what's log base 2 of 4? 2. So what is the new translation? Up 2. So now this turned into up 2. So horizontal dilation by 1/4 is equivalent to moving the graph up 2. Talking about the parents, okay? And that's what's happening there. Next one, f of x equals, well, we know what to do with this exponent. We know to pull it out in front. I can't call this dilation yet. I don't know what this is in terms of the original, right? But I know if this is squared in on that argument, then that's equivalent to, what is that now? 2 times ln of x minus 4. What would we call that? What would we call this? A vertical or horizontal? Vertical, stretch, or shrink. So that's a vertical stretch by 2 or a vertical dilation by 2. And we already had the 4 right. That didn't change. We could have said 4 right to begin with, but how do I analyze that squaring? We never really talked about anything like this. Okay, then here we go. Good factors, good FOILers are good. Good distributors are good. Because we're going to do the reverse of distribution here. What is the GCF? Oh my gosh, how many times people forget about GCF? Remember was this the class I laid on the floor in a ball because no one knew what GCF factoring? I think that was a very important day. the stress that you cause a teacher as they crawl in a ball in the middle of the class. 9 times 2 minus x. Wait, am I right there? Okay, good. This is the good FOILers, good factors. 9 times 2 is 18. 9 times negative x is negative 9x. Don't throw it back in there. You're going in circles. You're just checking that I did the math right. Oh, and then, you know what I could call this right now? This right now is a horizontal shrink by a ninth. And it's actually, oh man, we have a y-axis reflection because the x is negative, and this is actually 2 left. So right now, this is a horizontal dilation by what? By horizontal dilate by 1/9. This is 2 left because it's positive 2, and there's a y-axis reflection because the negative is on the x. That's actually what just happened there. That's actually good to cover for review purposes for the final. Yeah, we're gonna have questions like that just with a regular function. It could be any function. It doesn't have to be the ln or the log. Any functions affected this way. But then what they're really wanting you to do is use your rules to see what's an alternative look to this. Ruh-roh. I don't understand what that message just did there. And then this is 2 minus x. Hey, everybody, what's log base 3 of 9? 2 up. So really, what's the change then? Or what's the equivalency? The horizontal dilation by 9 just turned into up 2. Everything else stays the same. We would still be 2 left and a y-axis reflection. All right? And that's it. I don't know. Nothing special, nothing glamorous about this. It's a formula. Hopefully I heal and no one throws anything else at me.